Uh, for that purpose we need to have a periodic table having a certain ionization energy data, and if we want to find the position of that element, then we will compare it or its value with the given periodic table. For example, if there is an element which have ionization energy of 700, then it will be kept between those two elements which have ionization energies little below 700 and little above 700. For example, one have 730, the other have 680, then the element which we have that has ionization energy equal to 700, that will be kept between these two elements. Now we discuss the trends in ionization energies. The ionization energy generally decreases from top to bottom in groups and increases from left to right across a period, with few exceptions, like the first ionization energy decreases from beryllium to boron and from magnesium to aluminium. Students, as we have discussed, it is increasing from left to right, but there are some discrepancies, and one discrepancy is for example beryllium and boron. Beryllium has more ionization energy as compared to boron, because boron has one p electron while beryllium has two s electrons. The electronic configuration of beryllium is 1:2, 2:2. Its 2s orbital is completed. That is why its electrons are strongly bonded, or they are more stable and require more energy. Similarly, boron, which is electronic configuration is 1:2, 2:2, 2p1, it has one electron in its p orbital, and the removal of that electron is easier. That is why boron will require little amount of energy as compared to beryllium. Similarly, in case of magnesium and aluminium, magnesium has close electronic structure, that is 1:2, 2:2, 2p6 and 3s2. So the 3s2 electrons are difficult to be removed, while aluminium have 3s2 and 3p1, and the removal of 3p electron will become that is easier, so it will require little amount of energy as compared to magnesium. Next, periodic table organization. It means that if we have the data of ionization energies, then we can organize periodic table. Let's discuss. The periodic table is organized in such a way that elements with similar ionization energies are grouped together in the same column. This organization is based on electronic arrangement of the elements, which determines their chemical properties. We can arrange or we can organize different kind of elements in the same group if we know their ionization energies, and on the basis of these ionization energies, the scientists have organized a periodic table. Next, the comparing ionization energies. We can also compare the ionization energy of different elements. For example, to determine the position of an element in the periodic table, we can compare its ionization energies with known periodic table. If the element's ionization energies match the expected values for its position in the periodic table, we can confirm its position. For example, let's suppose that an element has ionization energy of 500, and we have a periodic table where there are spaces or there are locations nearer the 500 value. Then we can place that element in periodic table that will be between those elements which have a little more ionization energy than 500, and the next one that has little lesser energy than 500 kilojoules.